Today we're going to be talking about probability, guys. I'm going to give you the first question. It's a pretty easy question. Read through it and remember the things that we always need to establish, guys. Whenever we're looking at questions like this, we always need to know our sample size. And in this case, we've got two events. Look, I'm starting with the sample size. What a lie. Sample space and then sample size. And then we're going to need to find event space A and event space B. And then we're going to have to find event size A and event size B. Okay. Oh, Rami says paper one was okay. Kamachana, please tell us how it went. Oh, sorry, Oradilwe, tell us how it went. Okay. I'm going to give everybody about 4 minutes to do these two questions. Please pop your answers in the chat when you're ready. There are actually more questions involving this, so I'm going to let you guys just do this quickly and then I will scroll once we're done. Okay, 4 minutes, guys. I like that. No worries, Nicole. Teacher knows I'm just going to run and get some tissue because my nose is being funny again. Okay.
Okay.
One last minute, everyone. I love how Entla just throws in there like, oh, sorry, I'm late, ma'am. I had dance practice. So now I'm a dancer. Now we have to see her moves. You know, you can't just throw those things out there. We must now see you dance. Hi, Buhle. No worries. Hello, Dumiso. Sure. All right, let's have a look at these questions. Okay. Okay. Hello, Ayanda. That's okay, Jessica. I'm going to go through the questions now. All right. So let's look at this. It says here, a fair coin is tossed and a fair 6 die is rolled. So there are two things that are happening here at the same time. Right, so let's look at our sample space. Now, we know that if we flip a fair coin, we're going to get two options. What are those options, guys? What are those options that I get if I flip a coin? Good, Mfundo. Yes, that's it, Mfundo. Not A or B. We're either going to get heads or we're going to get tails. Okay, not the probability itself. What options do I have? Good, I have heads or tails. Now, if I roll a 6-sided die, what are my options? What are my options? I can either get, good, Nonjabulo, that's in Tlanganipo. I'm either going to get a 1 or a 2 or a 3 or a 4 or 5 or a 6. Good. So if I then have to look at my sample size, I'm going to get 2 different sample sizes, am I not? I'm either going to get a sample size of 2 or I'm going to get a sample size of 6. It's either going to be the dice or it's going to be the coin. All right. Okay, now let's write down event A. Event A is defined as getting a heads, or sorry, a tails on a coin. So event A is going to be tails. Now, what is my event size? How many events do we have in this particular event? How many options do we have? Not 2. Look at your event, guys. How many options are there in here? Inside this event, this one here. How many times good, Oratile, how many times can I get tails on a coin? How many times? Just once. Okay, just once. Good, just once. All right. Hello, Amogelang. Let's look at event B. They say event B is defined as getting an even number on the die. So let's look at our event space. What even numbers can I get on a die? I can get either a 2, good Mfundo, or I can get a 4, or I can get a 6. Now, what is my event size? How many options do I have? Good. Not the probability, just the number of options. Good. 3. Okay. All right, no worries. Okay, let's talk about this because this is a kind of a tricky one. I won't lie, it's pretty tricky. Now, the first question says, are events A and B mutually exclusive? Are they mutually exclusive? Yes or no? Okay, for those of you saying yes, I want somebody to explain why you say yes. I say no. And I'm going to explain why I say no. Those of you who say yes, do we understand why we're saying yes? Or are we just saying yes because it's the first answer that came to mind? Okay, let's think about it. Mrs. like, nah, ma'am, I don't know. I just said yes. Okay, I say no. Okay, let me ask you this. Is it possible for me to toss a coin and roll a die at the same time? Can I? Yes, I can. And is it possible for me to get tail on my coin and get an even number on my dice? Can those 2 things happen at the same time? Maybe. Yes, the answer is yes. They can happen at the same time. So my answer is not mutually exclusive. Remember, mutually exclusive means both things can't happen at the same time. Okay, that's what mutually exclusive means. But I can roll a dice and flip a coin at the same time. So no, it's not mutually exclusive. Why? Because there are no events in A that affect events in B. None of them affect the other. Okay, if I flip a coin and roll a dice, same time, the answer is going to be whatever the answer is. It doesn't matter which one comes first. Okay, now let's think about this. Are events A and B independent events? Mfundo says no, Ratulu says no, Jessica says no, Abigail says yes, 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 yes. I'm getting yes and no's and yeses and no's. Try and explain to me why you say yes, why you say no. Correct. Mfundo, I agree with you. So what is your answer? I think Mfundo said no. Mfundo, did you say no? Yes, Mfundo said no. And Mfundo is correct. Okay, because both of these events have to happen together. So we must toss a coin. So we must get an answer for coin, and we must get an answer for the dice. We must get for both. So are these events independent? No, because the outcome of the one and the other need to be at the same time. No worries, no worries. Is that Nomfiki? So I hope I said that correctly. Hello, Baswidi. All right. Coin and dice need to happen at the same time. All right. So because these two things are happening at the same time, we can say both events are dependent on each other. Okay. They do depend on each other, Abigail, because the question literally says that they need to happen at the same time. They're happening together. Yes, that's what the question said. Let's go back and have a look at the question. It says, a fair coin is tossed and a fair 6 die rolled. You see that? Both things must happen. So they are dependent on each other. Okay. Okay, now let's look over here. It says here, calculate the probability of A intersection. Remember, this is intersection. This means intersection with B. Now, remember, the intersection needs to be the things that they both share in common. Does event A have anything in common with event B? Do they have anything in common? Nope, they don't. Right. No, they don't. So the answer is going to be what? What is the answer going to be? Is there anything in the middle there? No, correct, Oratile. The answer is 0. The answer is 0. They have nothing in common. 0. There's no intersection between the two. None. Okay. So we could say that, but we could say that about anything. We could say that about the probability of rain or number of cars passing by. It has to be specific to an event. Okay. All right. Let's talk about P of A union with B. So let's go have a look at the probability of the union. So we know that the probability of A, what is the probability of A? Remember, the probability of A is tossing a coin and getting heads. It's not just one correct, Mfundo. Good. It's 1/2. No worries, Zippo, welcome. 1/2. And union means or. How do we express or? What do we do when we express or? What operation do we do? Or means what? Not times, the other one. Good, Isabel, that's it. It means add. So 1/2 plus. Let's go to event B. What is the probability of event B? How many options do we have for even numbers? Not 1. There are 3 numbers out of 6. Correct, Oradilwe. That's it. That's it, Mfundo. That's it, Nklanganipo. That's it, Jessica. Good naledi. Plus 3/6. Okay. You need to give me an answer, though. What's my answer over here? 1/2 plus 3/6? 1. Which doesn't sound very likely. Teacher knows, what did I do here? Should it be 1? It shouldn't be 1.
What was the question?
the probability of A union B. And it shouldn't be
How many
one.
events? Like we have 2 events.
We have 2 events, 2 separate events. So I need to go figure out what I've done here. Okay.
I think you have to subtract. Don't you subtract? No?
But the intersection is 0, so there should be a subtraction. Okay, let me see if I'm losing my mind. Okay, I'm gonna pop this one. We'll come back to it in just a little bit, guys. I have a feeling that I know that. I understand why, because this is half plus half. Okay, I will come back to this in just a little bit. I don't want us to run out of time. Okay, let's look at...
Yeah, you subtract the, the probability of both events, intersection.
Yes, but yeah, that's what I understand. But the probability of each event, of both events happening at the same time is 0, teacher knows. The intersection is 0. Okay. Or did I lie? I did. Teacher knows. What does and mean? How, guys? My lies. What is the probability of getting... Intersection means multiply. Guys, why are y'all just looking at me here like how, guys? It's not. The probability of A is 1/2 times the probability of B, which is 3/6. So the probability of A and B is multiply. Sorry, teacher Nels, I completely just flipped my mind. Somebody please calculate this probability for us. Thank you. It's 1/4. Yes, it's not the overlap. I'm thinking of Venn diagrams. It's not the overlap. It's the probability of you getting tails and an even number at the same time should be 1/4. Good. Thank you, teacher Nels. Sorry. So the probability of A or B should be the probability of A plus the probability of B minus the probability of A and B. And that makes so much more sense. Sorry, guys. Where's your stick? Yes, Oratile, but that's not true. They are not complementary. Well, technically they are, but not the events that we're thinking, not the tails and the even numbers. Heads and odd numbers would be the complement, so that's not it. Okay, can we work this one out quickly? Sorry, guys. So this is going to be 1/2 plus 3/6 minus, we've now got the probability of A and B, which is the intersection, 1/4. Thank you, Buche. That's the correct answer. And that is equal to 3/4. Please ignore ma'am's. Ma'am is not 100%. In my mind, I was like, heads and 6 together, Venn diagram, it's not the same thing. It's not the same thing, guys. I'm sorry. Venn diagrams only work if we're using one scenario, if we have one sample size. In this case, we have 2 at the same time. Okay. All right. Sorry about that, guys. I was testing you and we passed. Okay, that didn't actually work, but okay, let's look at this. All right, it says here, consider the Venn diagram which shows how 25 people travel to work. Their travel to work is represented by B for bicycle, T for train, and W for walk. Now, if we have to look, no worries, Matabele. If we have to look at what's happening over here, let's try, before we even look at the questions, let's try and understand what this is actually telling us. Okay, we know that these 5 people, how do these 5 people get to work? A Venn diagram. How do these people get correct, Mfundo? That is both bus and train, correct, beautiful. That means these 5 people use the bus and the train. Good, both. It's the intersection. Excellent. What do these 4 people do? These ones. Good. Not just, you can't say bus, guys. You must say just bus or bus only. This means only bus, because these 5 people also take the bus, but they also take something else as well. So we need to distinguish between the 2. All right, then we've got these 3. What do we know about these 3? Good, Mfundo. Train only. Train only. Right. Excellent. Let's talk about these dudes over here. These 7. What do these 7 do? They only walk. Good. I love that you said that. Walk only. Walk only. Okay. This is only walk. Now, here's my next question. If I walk, can I take the train or the bus? Yes or no? Okay. My answer, I see some of you saying yes. My answer is no. Who can explain to us why is the answer no? If I walk, can I take the train or the bus? Because it's not an internet. Good, Abigail, that's it. Mfundo, I 100% understand what you're trying to say. Just give me. Okay, good. Yes, the circle is separate, right? Which means there's no overlap. There's no both for that one because it doesn't touch any of the other circles. Tell me about these people. What do we know about these people? Lost. Mufino's like, they are lost. They don't do anything. They don't do any of those. So maybe they fly on a broom. If you're from Limpopo, you never know, right? Or maybe they have their own private car, unemployed. Or maybe they have a car, right? Or maybe, how do we know that this isn't one of those work environments where they have like houses on the top, like apartments on the top of the work building? So they don't have to go anywhere. They are at work, which sounds like a nightmare because I would never. Or they drive BMW, boarding work. I'm also from Limpopo. It's just a joke. The teachers that stay at school, Mfundo, shots fired because I also stay on campus. That sounds like a personal attack. All right, guys, let's have a look at some of these questions. Now that we've interpreted our Venn diagram and we're kind of getting where this is going, right? By the way, what is my sample size? What is my NS? How much is my sample size? Good, Siamtanda, that's it, Nyonjabulo. Everybody is 100% on point. It's 25. All of these numbers together must add up to 25. Okay, let's get to work, guys. Which events are not mutually exclusive? Remember, when you are mutually exclusive, there can be no overlap. If you are mutually exclusive, there cannot be an intersection. But if you are not mutually exclusive, that means there is an intersection. Which two have an intersection? Which of the two have an intersection? B and T, correct. B and T, the B and the T. The bus people and the train people together, intersection. Right, Hebo, W, no. Remember, Ramrata, we want the people who are touching. Not mutually exclusive means they must touch. All right. All right, let's see. Here's the next question. It's a bit complicated, but we must remember the rules. They've written them down here for us, guys. I'm going to highlight them quickly. This rule, the probability of B or T is equal to the probability of B plus the probability of T minus the probability of B and T. This is called the addition rule. Okay, this is called the addition rule. No problem, Oratule, you've got 2 seconds. 1.5. 1 5/8. Okay, cool. 2. All right, let's look over here. It says, Mark was asked to answer the following question. One person is chosen at random. Determine the probability of B or T. Right, now it says here, the addition rule is written over here. Let's look at Mark's solution. It says the probability of B is 9/25. The probability of T is 8/25, right? The probability of B and T is going to be B, probability of B times the probability of T, which is 9 over 25, 8 over 25, which is 72 over 625. So that means that the probability of B or T is 9 over 25 plus 8 over 25 minus 72 over 625, which is equal to 353 over 625. Now, his teacher said that this was wrong and that his mistake was on the third line. Let's go to the third line. Here's line number 1, line number 2, and line number 3, line number 4. Okay, we have to now go figure out. We now have to go figure out, why was Mark wrong? Clearly explain and justify to help Mark understand why his solution is incorrect. Let's go back to our Venn diagram. Just give me a thumbs up in the chat if we've all managed to draw the Venn diagram, because I don't want to go up, down, up, down. I want to make this smaller. Okay, give me a thumbs up if we've all got the Venn diagram down. Okay, excellent. I'm going to make this just a tiny bit smaller. Look at all my colors disappearing. Okay, that's fine. We know what all the colors meant. It's fine. Okay, cool. I'm going to take this one and I'm going to move it closer. And move it up. Okay, but we've already done that one. So I'm going to take this one and send it back. Okay, cool. Now let's talk about this. We want the probability. We want the probability of B or T, right? So let's think about this. Remember, here's the addition row, guys. There's the addition row over there, right? Let's think about this. Now, we know that we're going to have to find the probability of B. What is the probability of B, guys? What's the probability of B? Correct. Now, for all of you saying 9, that's not the probability. 9 is how many people take the bus. What we want is the probability of someone chosen at random taking the bus, right? So, Oratile, remember, this 5 also makes up part of B. So how many people are there that take the bus? 9. Out of how many? 25. Okay, because remember, guys, we want the probability. The probability is always event size over sample size. Good. Now, let's go look for the probability of taking the train. What is the probability of taking the train? Correct, Mfundo. Excellent. The probability of taking the train is 8 over 25. Right. Now we need to go find the probability of A and now I'm saying A, B and T. But we know that B and T is the what? What do we call B and T? What's another word for and in a Venn diagram? It's the what? Good, Bushe, it's the intersection. Correct. So how much is there? What is the probability of my intersection from my Venn diagram? What is the probability? Correct, Jessica. Beautifully done. Good. 5 over 25. Right. That's this intersection there. 5 over 25. Good. Now, let's put this into our formula. The probability of B or T is going to equal to the probability of B, which is 9 over 25, plus the probability of T, which is 8 over 25. Minus the probability of B and T, which is 5 over 25. Give me an answer. What answer do we get here, guys? Beautiful. You guys are super duper fast. Good. It's 12 over 25. All right. Good. Let's go look at, okay, our answer. Our answer is 12 over 25. Let's go look at Mark's solution. Let's go look at Mark's solution. Mark says 353 over 625. Our answer for the probability of B or T was 12 over 25. Where did Mark lose the plot? What happened? What happened? Good. On line 3, they're telling him that it's on line 3. Teacher Nels, can you help out Pamela, please? Thank you. Good. By getting 72, right? But we know that his formula sheet is not lying. His formula sheet is not lying, right? His formula sheet is not lying. His formula sheet says here that the probability of A and B needs to be the probability of A times the probability of B. However, what kind of event do we need in order for this to take place? Does it have to be an independent or a dependent event in order for us to use this formula? Independent or dependent? I'll give you a hint. It starts with I. Correct. It must be an independent event. It must be an independent event, right? However, we know that our event is not independent. Why do we know that it's not independent? Who can tell us? Why is it not independent? What do we have that shows us that it's not independent? Beautiful. Jessica, you're a whole genius. Good. We have an intersection. Therefore, this cannot be independent. So we cannot use the probability of A times the probability of B, because these things can happen at the same time. People were asked, do you take the bus or the train? And they said, I take both. Am I allowed to take the bus one day and then the train the next day? Can I do that? Yes, I can. So there's an overlap. So there's no way we can use the formula for P of A times P of B when these two things can happen at the same time. I am allowed to take a train one day and a bus the other day. I can do both. I'm not limited to just one. Okay. Okay. All right. Give me a thumbs up if you guys are understanding why Mark went wrong. Are we all okay with why Mark went wrong? It's like Mark was sick that day. Forgive my friend Mark. Guys, we need to help Mark. Mark mustn't get the answer wrong. Okay, Ramrata, where did I lose you? You need to tell me where I lost you. Joyous, please let me know as well. Okay, I don't want to leave you guys behind. An imaginary chat. Kind of. So Mark times B and T only to get 72. No. He used this formula. So this is what happened. This is what happened. Okay, let's have a look. Okay, so Mark knows that the formula for OR is the probability of B or T is the probability of B plus the probability of T minus the probability of B and T, right? On both of these, okay? But he knows he can calculate the probability of B, he's correct there. The probability of T, he's correct there, right? Now he used this probability, the probability of B and T. He's absolutely correct. This is the formula for the probability of B and T. But we can only use this formula if we have independent events, okay? Independent events. Now, remember, independent events means that both things can happen without the other. I can take the train and I can take the bus. They don't have to happen at the same time. Not at the same time. They don't, it's not like you can take one and not take the other. It's not like if I decide to take the bus, next time I can't take the train. I can. I get to choose that, right? So there's an intersection, which means my events are dependent. They are dependent. So I can't use this formula to find the probability of B and T. Okay. All right. So Joyous, I'm going to show you how we can identify. Okay. Yes, Mfundo, good. We have the option of both. Okay. So Joyous, if we look up here, do you see how if I take the train and the bus, I can't walk? I don't walk, right? So these two events are independent. Because if I've chosen train, I can't choose walk. And if I've chosen walk, I can't choose bus. So they are independent of each other. All right. But in this one, in these two over here that intersect, if I choose train or I choose bus, I can also choose train and bus. I can choose them both. Okay. Joyous, am I making sense? Okay, so they are dependent because I can do both. Okay, I hope I'm making sense. All right, so we can't use this equation. We can't use this one because they are dependent on each other. I can take the bus or the train, either of them. I get to choose which one I want. But if I walk, I can't do the train or the bus. And if I take the train or the bus, I can't walk. Okay, because there's no overlap. Got me? All right, excellent. Okay, let's look at this next one over here. This one is a bit tricky. No, other way around. Other way around, Timuluho. Other way around. W is independent and B intersection with T is dependent. Okay, other way around. Okay, all right. Let's see what they're saying over here. Using only the symbols A, what does this mean? Who remembers what does A with a little at the top mean? What does that mean? A what? Good, Oratile, excellent. It means not, or it means the complement, not A. Beautiful, good. So we can only use A, not A, B, not B, and the words and, or. Those are the only things we can use to classify the shaded region. The shaded region. Let's look at number one. What do we know? What can we call this shaded region over here? What can we call it? I know for a fact that the first one is A, right? And the second one is B. But what goes in the middle over here? Jessica, you're a whole, like, crushing it. Rami, crushing it. Beautiful, Oradilwe. But remember, we must follow instructions. They want us to use and or. So we're going to use and. Excellent. The intersection is and. Beautiful, beautiful, beautiful. Let's look at this next one. I know I'm going to get A. I'm also going to get B. What happens in the middle here? Good. You guys are amazing, Jessica. Good. Okay. Joyous, remember, let's say, for instance, A is ice cream and B is sorbet. So the people who like ice cream go in here. The people who like sorbet go in here. The people who like ice cream and sorbet would be in both circles. So they must go here. Okay. They must go in the middle. That's why we say and. Now this one over here is or. Sorbet is like frozen yogurt. Okay. Ma'am has money for sorbet. Guys, I know the name of sorbet. I didn't say I can afford it. I didn't say I can afford it. All right, let's look at this one over here. This one is a little bit tricky. All right, Masudi, you're very welcome. I wish, guys, I'm a teacher. I am a teacher salary, please. Okay, what do we do with this one over here? Okay. Okay, good. You're onto something, Jessica, but you've added an extra thing in there. But let me see. Reamorata, Amogelang, and Oradilwe. Correct. Mfundo, let's talk about this. Now, I want you guys to note how they have shaded the whole thing. They've shaded the whole thing. And guys, we've said that the probability of all events together must equal what? How much must they equal? If I take all the events together, how much must they equal? Good. They must equal 1. Good. They must equal 1. But what have they taken out? What have they not shaded? A. Good. So the only thing that's stopping them from getting 1 is A. Yes? So the shaded area needs to be what? Not A. Everything except A. So A complement. Okay, because if we had to calculate for the for the probability of this, we would say 1 minus A. And we know that 1 minus A is complement of A. All right, give me a thumbs up if this last one over here makes sense. Are you guys with me? Beautiful. Excellent. Yes, correct. Somebody just said ma'am was 2A or B. Yes, Abigail, correct. Okay, beautiful. Let's talk about this one. This one is a tough one. That's why it's worth 2 marks. Okay, the others were worth 1. Let's talk about this one. Yeah, but there's no only, guys. There's no only. Let's go look at the things that we can use. We can only use A, not A, B, not B, and an or. There's no B only. There's no B only. Okay, and for those of you who are saying B, they've taken out a piece of B. They've taken it out. They've taken out a piece of B. And Boitumelo, we can't say not A because, who said that? Who said that? We can't say not A because the whole thing, Jessica and Mfundo, you guys are whole geniuses. Okay, let's think about what they've actually done. Let's think about what they've done. So we know that at some point, they colored the whole of B. The whole of B was colored in at some point, right? Which means that the whole of A must have also have been colored at some point. So what do we call it when these two things are colored in like this? What did we say this is? This is what? Good, it's or. We're going to get A or B. But then they've minused one of them. Which one have they minused here? They've minused? Good, Jessica. They've taken out A. That's a joyous and buche. Beautiful. So what does this tell us about A if they've minused it from the whole? That A is what? Correct. Oratilwe, not A. Beautiful. The complement of A. I'm so chapped. Teacher Nows, y'all are so smart. Like different levels. Different levels. Because that means we are seeing the probability where we need to see the probability. Well done, guys. Amazing stuff. Okay. I want us to try one more question before we run out of time because it is quiz day also. Okay. Yes, Ramorata.
Hello, ma'am. I wanted to ask, how do you see if it's or?
Okay,
like, how do you?
Okay, do you see how or is? Or means you can belong to any of the 2 circles. Okay, but do you notice, Ramorata? Let's notice here. Do you notice in order for it to be B, A or B, this middle section must be colored in for B and it must be colored in for A. Yes?
I'm still
Are you understanding what I'm saying? No, are you lost?
Ma'am.
Okay, let's talk about this. Let's take that same ice cream and sorbet idea. This is ice cream. This is sorbet, right? So if I ask everybody in the class, we're not actually going to do it, guys. Okay, we're not actually going to do it. If I say to you, do you like ice cream? Right? You're going to put your hand up, right? And then if I say, do you like sorbet? Some people are going to put their hand up, some people are not going to put their hand up, right? But if I say to you,
Yeah.
I'm serving ice cream and sorbet, you can choose ice cream or sorbet. Which people are going to put up their hands?
All of them.
If I say I have both desserts, sorry, Amkhelang, I heard myself. If I say I have ice cream or sorbet, which people are going to put up their hands? Is it not going to be everyone?
It's gonna be everyone.
Yes, it's going to be everyone. That's why or looks like that. Everybody for ice cream and everybody for sorbet. Because everybody's going to put their hand up. Ooh, ma'am has ice cream. Ooh, ma'am has sorbet. Both hands up, right? But if I say to you that I have ice cream or sorbet, but I'm going to mix them together to make a new dessert, which people are actually going to come forward? The people
who like both.
Yes, because if I only like sorbet and I'm like, how ma'am put ice cream inside, I'm not going. Because I don't want ice cream. But if I also like ice cream and I'm like, how ma'am put sorbet, I'm not going because I don't want sorbet in my dessert. Do you understand the difference?
Yes, ma'am.
You got me. Okay, now let's go down here. Let's go to this one over here. Do you see how they've chosen the people who like sorbet? Do you see that they've chosen the people who like sorbet, right? Yes?
Yeah. Yes.
But who did they minus?
Yes, ma'am.
Who did they minus?
The both ice cream and sorbet.
Correct. But where does that come from? These people who like both ice cream and sorbet, which group do they also come from? Which other group do the ice cream and the people here in the middle, which other group do they also come from? They were part of the sorbet. What other group were they also part of?
Ma'am, can you repeat? I can't hear you clearly.
Okay, so we know that the people in the middle are ice cream and sorbet. Agreed?
Yes, ma'am.
So they've been minused from the sorbet group. What other group have they been minused from?
The ice cream.
Correct, the ice cream. And we know that ice cream or sorbet put together, all of this put together is or. Agreed?
Yes, ma'am.
But now they've taken these people away. Who are these people on this side here? Who are they? They are not.
Yeah, ma'am. This is really bad. I can't hear you.
Oh, okay. All right, my sweetie, I'm sorry. I don't know how to fix that. Okay, no worries. Okay, I think we're gonna run out of time. But my sweetie, I'm gonna have to try and explain to you if you want, please go have a look at the recording because I don't know. Teacher Nels, can you just give me a thumbs up if you can hear me? Or I mean you can also give me a thumbs up. Okay, thanks. All right. Yes. So I'm going to ask Teacher Nels to put the quiz link in the chat. Excellent. And then somebody said to me, ma'am, can you explain how union works? I'd raise my hand, but I can't talk right now. Okay. Remember, Zipozonke, union means that you can belong to either group. It doesn't matter which group you belong to. You just have to put your hand up. Okay. Let's think about this. How many of us like, let's go back to union here. Let's go back to or, because or is union. Okay. Union means or. This is union. All right. So let's say, for instance, this is comedies and this is action movies. These are action movies, right? If I say to you, I have a playlist or my Netflix has comedies on it and action movies on it. Everybody's gonna come. The comedies people and the action movies people. Everybody's gonna come. Okay, including the people who like both. Including the people who like both action and comedy. So this is action or comedy. Doesn't matter in which direction, comedy or action. All right, so the union is the, like everybody in here and everybody in here. All right. Cheers, everybody else. Okay. You're very welcome, sweetie. If any of you would like a little bit more practice, I know some of you are writing maths soon. I don't know if you guys actually do two-way tables. I doubt it. It's a grade 11 concept. Hey, teacher Nels. I think two-way tables are a grade 11 concept, yes?
Yeah.
Okay, that's fine. All right, okay, I'm gonna have to leave you guys, everybody. I will see you guys again on Monday. All right.